consume less y as I move from point A to point B. And that decreases my utility. By how much? I'm approximating, that's an approximation of the utility change because I consume less y. That's what I have. And this approximation of the utility change, first of all, why is it an approximation? Because I'm only using one marginal utility measure, and I know marginal utility keeps changing. It's a little bit different each time, right? So for this unit and the next unit, it's just slightly different, I know, but I'm approximating. Perhaps I pick the middle marginal utility value between those quantities to get it right. Okay, so it's an approximation, a good approximation of my utility, of my decrease in utility because I get less y. And I'm going to say that this decrease in utility has to be the same with my increase. So this is also an approximation. So of the utility change because I consume more x. I'm applying the definition of an indifference curve. As I move from A to B, my utility, my happiness is less because I consume less y, but my happiness is also more because I consume more x. And the two changes, the two approximations, the two changes in the utility have to be the same. Otherwise, I wouldn't be in the same indifference curve, along the same indifference curve. What is the approximation here, where it's dx times marginal utility of good x? The one is positive, and the other one is negative. My utility decreases because I consume less y, and increases because I consume more x. So I need a negative sign somewhere when I set them equal. I need a negative sign. And then I'm basically saying if points A and B are along the same indifference curve, this has to hold. You guys are with me? Good. Well, this is the equation we use to derive the slope, because we have dx and dy and dx, so you can rewrite this equation, and that's all you have to do. So you go dy over dx, that is minus the marginal utility of good x over marginal utility of good y, and that is the slope of an indifference curve. Slope in an indifference curve. So, we have gone far. We understand what an indifference curve is. We understand that it should have a negative slope. We understand that in particular, in most cases, tends to be convex. Not always, but it tends to be convex because of the diminishing marginal, the law of diminishing marginal utility. And now we have also figured out the exact slope, which is the ratio of the two marginal utilities. This is what we also call the marginal rate of substitution. The marginal rate of substitution is the positive part, is the absolute value of the ratio. Marginal utility of good x over marginal utility of good y. That's the marginal rate of substitution. With a negative sign ahead of it, we know it's the slope of the indifference curve. So far, so good? The last characteristic is that indifference curves do not intersect. I have this in my notes that you have for me. They do not intersect. So when I have all random indifference curves, notice that I carefully graph his indifference map this way. And then I graphed mine. And I said perhaps they're steeper. Okay? So I have the red indifference map, and he has the black one. So if I put them on top of each other, yes, they would intersect because they belong to different people. Okay? When they belong to different people, that means different preferences, then yes, they would intersect. But in general, when we graph indifference curves, we just graph it for one person or one group. So they should not intersect. Why? like the black and the red in this example, then you can't make sense of what's going on. Because you say point A and B are along this one indifference curve, so that means that you're indifferent between A and B. But then is this red curve really a different indifference curve? Because the red one also has point B on it, right? Only when you have an intersection. And then we are saying that, okay, is the red one a higher or a lower indifference curve? It doesn't make sense because you have one point that belongs to both of them that means the same level of utility. Because typically you look at an indifference curve and you say, this is utility perhaps 15, and this is utility 12, and this is utility, level of utility. I'm making up numbers, and this is perhaps 3. But notice I keep increasing the numbers to imply that I like it better, I like it better, I like it better. So, and each point along this one indifference curve represents the same level of utility of 15. And each point along this next one of 12, and these of 9, and so on. So, if I have an intersection like here, then I can't make sense of anything, right? So that's a book. Now we have all the pieces, we're going to put it together. This is the most exciting part. Okay, we understand about budget constraints. There are slots, there are shifts, they can shift and rotate, right? But they really tell us what we can afford. We also understand about indifference curves, right? And notice that now the axes are the same for both budget constraint and indifference curve. So we can actually put them together. If I'm a consumer and I have income of I and there's a price of good X and a price of good Y, then I can come here and I can just say quantities of good Y, quantities of good X. I can tell you all about what I can afford because I can find this intercept, this income over price of good Y. I can find that intercept, income over price of good X, and I can sketch my budget constraint correctly right there. And I also know that my budget constraint has a slope of minus px over py. That's all I can tell you about a form. Okay? I can buy all of these things. I can afford them. Am I going to buy all of these things? No. We don't buy everything we can afford. How will you pick what I'm going to afford? I have to turn around and think, consider my preferences. Consider my indifference map. Maybe it's the black one, maybe it's the red one, maybe it's a different one. I bring it in. So I bring it in. I'm going to bring some of these indifference curves, not all of them, because it's going to be very messy. Because they keep going. So I have 3 of them right there. My indifference map is like this, 3D blue indifference curves I just sketched for you. And let's understand the consumer equilibrium first intuitively. The budget constraint really says I can only be anywhere in the opportunity set here up to the red line, my budget constraint. Given my preferences, I'm willing to spend all my income. Where am I going to be? Where am I going to be in equilibrium? You guys are showing me, but somebody raise your hand and really tell me. Where's the equilibrium point? It's kind of graphed, but not really made very clear, because I want the point. Yes? Use the appropriate word. Follows along, just one word. Tangency. Yes. You agree? Tangency? Okay. That's what's important. Right there. That's your consumer equilibrium. Point of tangency. Why? Because this is the highest level of utility happiness you can reach, given the budget constraint, right? You put something somewhere in here, but you're not as happy. It's a lower indifference curve. Could you be somewhere along this indifference curve? You cannot afford it. So you're trying to reach the highest possible indifference curve you can reach. So by definition, it has to be one that's tangent if it's convex, right? If they're convex. One that's tangent. That means consumer equilibrium is right here. That means we got the answer. This is what's important. You guys, the answer is not in the intercepts. The answer is right here. You indifference curve, you say, oh, really? Oh, yeah. You're trying to maximize utility, your preferences, given your budget. Okay, so we understand the intuition, right? Now let's do it. We can understand it in a lot of different ways, this equilibrium. If we have a tangency, math tells us, in equilibrium, if you have a tangency here, tangency means the slopes are the same. That's what a tangency is. So in equilibrium E, the two slopes are the same. What are the two slopes? Slope of the budget constraint minus px over py, that's the slope of the budget constraint, and it has to be equal to the slope of the indifference curve. What is that? Minus margin rate of, okay, I'm sorry. I get too excited. My hand moves even faster than my mouth and my mind. Okay, so it's minus marginal utility of good x over marginal utility of good y. So what is this? Slope of budget constraint. What's this? Slope of indifference curve. Okay? The two have to be the same. Only then you are in equilibrium. The two slopes have to be the same. I have this summarized in this page right here that you have thrown in. What is the slope of the budget constraint? It's the rate at which markets allow you to trade good X for good Y. The relative prices is how the markets allow you to trade the two goods. And what is the marginal rate of substitution, or minus marginal utility of good X over good Y, is the rate at which consumer wants to trade good X for good Y. Okay? So that's what we're talking about. So I'm going to put the equilibrium right there, big. And this is the page that I've scanned for you, so you have it. So in equilibrium, we have a tangency, therefore we have the two slopes being the same. We write this condition this way, or we simplify most often, and we say we get rid of the minuses. So we want px over py to be equal to marginal utility of good x over marginal utility of good y. So at the point E, at the equilibrium point. Okay? Okay. Another way to think about this, the same equation is that at equilibrium this holds, or let me rewrite, marginal utility of good x over price of good x equals to marginal utility of good y over price of good y. That really says that a consumer spreads his or her income in an optimal way, maximizes its utility while it does that, only if marginal utility per dollar spent across all goods markets is the same. All goods markets. So I can keep going here. I can just tell you if you had a good Z, and if you had a marginal utility of good W over price of good W, etc., etc., etc. That really says you are only maximizing utility. You're reaching the highest possible indifference curve you can. If you spread your income, you purchase goods in a way that marginal utility per dollar spent across all goods is the same. Ooh, all right. Now I'm going here, and I'm graphing it again. And I'm saying point E is right here, quantity of good Y, quantity of good X. What happens at the point like A? What happens at the point like B? Obviously, you're not maximizing utility. Let's say point A. If you're at the point like A, there is an indifference curve that goes through point A. Is this indifference curve higher or lower than at point B? Lower. So you have less utility. Not a good time to be talking because, it's never a good time to be talking. So if you're at the point A, what exactly is going on? of the budget constraint. So at the point like A, marginal utility of good X over marginal utility of good Y, the slope of the indifference curve, is steeper than the slope of the budget constraint. Or you can rewrite this and you can say marginal utility of good X over price of good X at point A is actually higher than marginal utility of good Y over price of good Y. So are you buying the correct amounts of X and Y? Are you spreading your income across all goods so that marginal utility per dollar spent is equal? No. Probably you're going to get more marginal utility from good X per dollar spent towards good X. So this would say if you are at the point A, this is what's going on with the slopes, and since you're getting more utility from good X, get more X, so buy more X, less Y. And if you do that, less Y and more X, you move towards E. Ooh, we nailed it. So you are increasing your utility and you're finally reaching the highest possible utility. If instead you would be at a point like B, so I can continue with this application at the point B, what happens at B? Again, you are down here, there's some indifference curve that goes through point B. It's a lower indifference curve clearly than the optimal one, it's not the highest you can reach. So you're not maximizing utility, you know that. Well, you want to find out what's going on with the relationship at B. The slope of the indifference curve, I'm bringing a tangent line right there. The slope of the indifference curve is now flatter than the slope of the budget constraint. So at B, the following is true. Marginal utility of good X over marginal utility of good Y is smaller than the relative prices, which is the slope of the budget constraint. I can see this from my graph, flatter than the budget constraint. And then I can just take the next step and say marginal utility of good X over price of good X now is smaller than marginal utility of good Y over price of good Y. So now we are saying at B, we gain more, marginal utility per dollar spent is higher for good Y, so buy more Y and less X. To maximize utility. More Y, less X, and more Y. That brings you towards point E. This is the deepest part of the basic consumer theory, and it's summarized by me here in this one page you have. If you have all this written down from me. You are in equilibrium at the point E, and this is what calls equilibrium. At the point like A, lower indifference curve, and this is what's happening. And at the point like B, again lower indifference curve, and that's what's happening. So this is all summarized. I brought you to the place I wanted to bring you. Are you all with me? That's the question, really. Could you see the big picture now? We're going to take even deeper and more clear dives into this material. Classes next week, super important. When we learn about income and substitution effects with all the graphs you have from me already on Canvas, so a good idea to bring them here so you don't have to graph them, you really pay attention, so you really get them. Okay, so next week is the peak of difficulty. Again, I'm going to say the same thing when we do oligopoly in about a month. That's another peak of difficulty for 101, so don't miss lectures, all right? I'm going to use, unless there are any questions, I'm going to use the remaining time to tell you about your exams, okay? Your teams are not here right now because they're hard working, sorting everything so that you get them in discussions. Now, I want you to be quiet though so that I can talk. Do not back up, it's not polite. I see half of you backing up, the other half being very polite. Can we all be polite? Let me tell you about the exam. You need to be more quiet. I'm going to wait until you're quiet. Thank you. So, this is the scores from the testing center. They give us more details. So I folded it in. Each star is one of you. You're all stars here.
I got the 27th problem.
99. So this is the distribution, so that really tells you. 99 is when somebody has really a perfect score. So this is before Andy adds the extra point, okay? 99 means you got all 33 problems correct. So we got 5 people nailing 100 out of 100. We have a lot of people, you guys did really well, in the 90s and 80s. As you can see, this is the distribution. I'm worried about the tails here, okay, and what's going on here, but this is all very, very good. This is only one test that is 20% of your grade. There's more coming, and it's only getting harder, okay? Well, I'm an honest person. I told you I'm not a liar, right? Yeah, so, it's not getting harder because you did well, it's getting harder because the material is harder, starting with chapter 6, right? You know that. So, again, this is from the testing center. You guys are very loud now. This is from the testing center, so that gives you overall statistics. So I'm saying from the testing center, so you know 33 problems were graded, 398 students took the exam. That's our lecture. 398 people took the exam, 33 number of items. These were the questions, the mean. But this is before Andy. That's why I put it in parentheses, because Andy adds a point to almost all of you if you filled out your Scantron all right. So the mean is 74.4 really for the class. Maximum 99, really 100, you know. Minimum 27, really 28 with the extra point. So now these are also important. First quartile is at 85, really at 84, really at 85 with the extra point. That means a quarter of you are above 85 and above. This is excellent. And the next quarter takes us to the median. So half the class has a 76 or higher with the extra point. And the third quartile is 64. I'm worried about the people below 64. Okay? Now, you want letter grades, I know. What type of letter grades would I give given this exam and given how you did? So if you scored anywhere between, and this is with the extra points, between 88 and 100 is an A. It would be an A just for this exam, okay? A lot can change. So if this exam didn't go that well, if you're down here, make sure you start climbing, okay? And if you are up here, don't fall asleep on anything because things will get harder. You know, you miss a lecture, you're going to feel like you're derailing, okay? So, all right, you want to hear what I have to say or no? Yes. Can you please be more quiet? This is how I would grade. I'm giving you an idea. If this was the only exam I had from you, the only piece of information I would have from you, a lot can change. Like I said, this is only 20% of your grade. You are in college now. So for some of you, for the first time, most of you are freshmen here, so you need to hear all this. Take this very seriously. A bad grade right now is not a disaster at all. It can change, but it's an indication that you didn't do something right. So you have to really change everything completely, and you can really make a big difference if you take this seriously. A real good grade can also be very dangerous because if you relax, seriously, things will get harder here in this class. See, that's how the nature of the material, right? You'll be looking halfway through the semester at comparative advantage and elasticity, and you're going to be saying, gosh, these were easy stuff. This is hard. You know, that's how it goes in this class. It just feels harder and harder and harder. So you really have to keep up with it. You're getting your exams back in discussion this week. Answers have been also posted on our Canvas. Andy will be posting the scores after lecture today. So he has them all on the grade book. He's going to reveal them after lecture, so your scores. Now, what do? Spend some time with your exam. TAs will go through some of the harder questions in discussion. Very important discussion this week, okay? You want to make sure you know what you missed after you go through it. If you don't, you talk to TAs, you talk to friends, you still don't get it, come to me. Then, guys, you're too relaxed. Then, after you go through your exam and you really know now what you missed and why you missed it, this is something you need to do with college classes a lot more than you ever did before. Reflect on it. Just say, all right, now I get the answers. But why didn't I come with answers for these 5 problems or 2 problems or 6 problems? Ask yourself. Depending on the answer you give yourself, you know the strategies you need to put in place so you do better next time. Was math the issue? Was knowing things incompletely, not quite well, the issue? The bottom line is that if you make this material yours and you practice a lot, you can all be right. Okay? I'm putting a lot of extra office hours next week. I want to see the students who scored a D or an F in this exam. And I'll be happy to see anybody else who is disappointed and feels discouraged. When you come to me, you should have already gone through your exam and try to understand everything you missed. Ask friends to go through problems, your TA. If you still don't get it, of course I put you go through it too. But use my office hours. You just come, this is what happened. I'm going to ask you, did you have this reflection? What do you think is your weakness? Most students say, I knew things 90%, not 100%. If you knew things 90%, your score is probably in the 50s, not 90%. That's how it goes. You knew them 90%, your score is not going to be 90%, your score is going to be in the 50s. Okay, that's how much lower. So a lot of you just have to really work very hard on getting to that. Overall, I am very pleased. If you did a good job, please keep it up. It's not going to be easy. If you're struggling, don't give in, don't give up. A lot can be improved. Stop by and see me. I'll help you. All right? Take care, you guys.